So when we were looking at the difference of squares there, that's the first example, not the second example, but the first one would be connected to the formula for a geometric sum, where there were just two things being added. So when we had the thing with an area of, what was it?
There was an 8 and a 21.
Okay, so the 8, we got that from 3 squared minus 1 squared. The next one in that one, you could have 1 plus 3 plus 9. And I actually have that one right here. So here's how I'm going to try phrasing this. Taking a look at this pair here, I'm not looking just for the volume, but to express that based on the layers there as things being added up and expressing those as powers. So do you think you can do that for that one?
So you're saying like,
So we've got 1 plus,
and then you go to 2 and then 4?
okay, express,
But like
so,
in powers?
yeah.
1 and then got 2 to the first power, and then you could do 2 squared. Is
Yep.
that what you're looking for?
Yep. Okay, if you could hold this a moment. Guess I would need to be down here, right?
Right.
We've got 1 plus 2 plus 2 squared, or 1 plus 2 plus 4, which is giving us 7. All right. Okay, so now let's take a look at the solid blue one there. And we're not looking at the layers anymore. We're looking at that in the same way that we're looking at the thing taken away. So overall, before that one spot got taken away, what's our volume?
You have the 7, wait, 2 times 2 times 2 is, yep, 7.
Okay, so 2 cubed, giving us 8,
Minus 1.
taking away the 1. Okay, I'll have you hold that again. And actually, we can express the 1 as 1 cubed.
Yep.
In that case, we're getting exactly the same thing. Okay. All right. So let's take a look at the next pair. That one I already gave away. That would be 1 plus 3 plus 9, or 1 plus 3 plus 3 squared. Okay. And same kind of thing there. We've got a cube with a volume of how much before you take away the...
The 27.
Okay.
But then you take away 1. So 26.
Okay, so here we had 1 plus 3 squared, i.e. 1 plus 3 plus 9 for a total of 13, right? Okay. And the 27, express that using a power.
3 cubed.
Okay, so 3 cubed minus 1 cubed. It's going to give us 27 minus 1, which is 26. And is there another color here? Yes, there is. Here, let's use one that's very close to purple that probably won't show up as very different.
Right.
But 7 and 7 being exactly the same. 13 and 26 not the same. But we're going to take a look at one more pair here. I guess I'll have enough room to put it on here. Sort of, kind of. All right. So again, expressing the volume of this one, similar to what we did right here and right here.
Oh gosh, 4 16 by 3. Lord.
There is 16 at the bottom.
21.
4.
21.
Okay. So expressing that this way,
Mm-hmm.
how would we do that?
Do you want the 4 squared?
That would be the last one.
Uh-huh.
So 1 plus 4 plus 4,
4
squared.
squared.
For a total of 21. Okay. And then that one. Okay, so we're
times 4 times 4 is 64, so then 63. Right? Did I do my math right there?
Mm-hmm.
Cool.
okay. Get all that again. All right, so we've got 4 cubed minus 1 cubed.
Uh-huh.
64 minus 1, 63. All right.
Mm.
So this pair
Stayed the same.
got exactly the same.
Mm-hmm.
How are 13 and 26 connected?
Doubled.
Okay. 13 times 2 would get us 26.
Mm-hmm.
Okay.
Mm.
And we're going to look at one more here in a moment.
Mm-hmm.
But similar to how, with the difference of squares, well, I'll hold off a moment.
Mm-hmm.
Does 21 go into 63?
It's tripled.
Okay, 21 times 3, giving us 63. Okay. Just like with the difference of squares, we're looking to write this as a product of two things.
Mm-hmm.
The fact that this stayed the same,
Uh-huh.
we could say that we had multiplied it by 1.
Mm-hmm.
Any idea why, when the common ratio that we would multiply, in that first example, that was 2,
Mm-hmm.
that we're multiplying by 1 here. Here our common ratio is 3,
Mm-hmm.
we're multiplying by 2. And our common ratio here is 4, we're multiplying by 3.
Yeah. N minus 1.
Okay, so it's 1 less than what that common ratio is.
Right.
So formulaically, what we're getting is, not that we'll express it this way with them, it'll
Right.
probably be something expressed in words, but the geometric sum part that we're looking for here